This lesson is about electrolysis of solutions. It's a slightly different situation to when you have electrolysis of just one compound. The first thing to consider in this situation is how many ions are present in the solution. Well, there'll be 4 of them because there'll be ions from the water, hydrogen and hydroxide, but also 2 more ions from whatever is dissolved in the water, such as sodium and chloride. So if you have 4 ions, what exactly is going to happen at the anode and the cathode? Well, there are competing reactions. Sometimes it's the ions from the water that react, and sometimes it's the ion from the dissolved salt. But first, we need to look at what happens when water undergoes electrolysis itself. So in the case of water, we're going to have hydrogen ions being discharged at the cathode, because they're positive being attracted to negative, and hydroxide ions being discharged at the anode. The hydroxide ions contain hydrogen and oxygen, so they produce water and oxygen. The half equations are written on the slide as well. During the electrolysis of a solution, we have competing ions. The hydrogen ions compete with the other cations that are in the solution, and the hydroxide ions compete with the other anions that are in the solution. This means that we need a set of rules to work out which ion is going to be discharged at each electrode. In order to predict which of the 2 products, hydrogen or the metal ion, that will be discharged at the cathode, we have the rule that hydrogen will be discharged unless the metal ion is lower in the reactivity series than hydrogen. The anode, where the negative ions will be discharged, will be oxygen unless the non-metal ion, the other one, is a member of group 7 in the periodic table. So chlorine, bromine, fluorine, iodine. Now this reaction is of sodium chloride solution. Sodium is more reactive than hydrogen, so hydrogen will be produced at the cathode. Chlorine is in group 7, so it will be chlorine rather than oxygen that will be produced at the anode. We can test for chlorine by using damp litmus paper, and it will be bleached by the chlorine. In this case, we're collecting the gases in the 2 upturned test tubes. And then let me test for hydrogen. I'm sure you're familiar with the blue solution, copper sulfate. So copper is less reactive than hydrogen. So copper will be produced at the cathode, whereas sulfate, sulfur and oxygen, they aren't members of group 7, so oxygen will be produced at the anode. This is the electrolysis of potassium bromide. We can see at the cathode that there are bubbles because hydrogen is being produced. That's because potassium is more reactive than hydrogen. At the anode, we can see that it's surrounded by a brown solution. That's bromine, and that's because bromine is in group 7, so we have bromine produced rather than oxygen.
This is bromine.
Here are some examples of how you might write it in a table. These are the key questions for this topic. You may need to re-watch the video to make sure you can answer them.